Alright, ladies and gentlemen, continuing today with chapter 2-7, we're going to be solving percent problems by writing and solving an equation. So these are going to be word problems that involve percentages. Don't forget to double check and make sure all your homework scores are filled in. And you're also going to be getting back quizzes today that you need to fill in out of 10 points. So, as we talked about in the warm-up, direct translation is really going to benefit you. So in looking at these examples can typically come up in any real world situation, but it's really easy to translate them if we directly look at the equation. So what is going to be our variable is, remember, means equals. 9%, we need to write that as a decimal, 0.09 of 65. Of means multiply times 65. So this is really easy to solve. We simply need to plug into our calculator 0.9 times 65. 9% of 65 then is x equals 5.85. Let's try translating the second one. 36 is 6% of what? Multiplied by x. Opposite operation, we're going to divide both sides by 0.6 because we're trying to get the x alone. .36 divided by 0.06 gives us 600. So x equals 600. Let's think about that. 36 is 6% of 600. That would make sense. 36 needs to be smaller than 600. Let's direct translate this last one. 24 is what percent of 144? Divide both sides by 144. 24 divided by 144 gives me x, oops, wrong color, x equals 0.16 repeating. Now, this is where it's really important. We need to remember that it's asking what percent. Is that a percentage? No, it is not. To make it a percent, we multiply by 100. Just like to make it into a decimal, we divide it by 100. So the percentage is 6.6%. 6.6 repeating percent. All right? So those are the simple ones that require direct translation. Let's look at some more complicated applications of this. Mark is taking Peggy out to dinner. He has $66 to spend. If he wants to tip the server 20%, how much can he afford to spend on the meal?
Okay, so what we have here is we have the cost of the meal that we're trying to figure out. So we're going to let n equal the cost of the meal. Alright, so we've got the cost of the meal, which is 100% of n, plus we've got the tip that he wants to pay, 20% of the actual meal, and that's going to give us a total of $66. Another way to think about this is 100% of the cost of the meal plus 20% of the cost of the meal times the cost of the meal. Okay, so we're doing 120%. That's 1.20 times n is 66. So backwards through PEMDAS, divide both sides by 1.20, and 66 divided by 1.20 gives me $55. That means that he could spend $55 on the meal. And if we did the math, we would see that the tip would end up being $11. Remember, 55 times 0.2 or 20% will give us the tip $11. So that's a bit more complicated. It's an application problem. Let's try another one. Julie bought a leather sofa that was on sale for 35% off the original price of $1,200. What was the discount? How much did Julie pay for the sofa? So discount, you're going to take the rate and multiply it by the price. So the rate is 35%, and again, we're changing this to a decimal, and the list price is $1,200. So the amount that is going to be discounted, 0.35 times 1,200, the discount is equal to $420. So the amount paid then is the list price, $1,200, subtracted by the discount, decreasing the price because it's being discounted, and that gives us the amount paid, $780. Okay, it's a little bit less complicated of an application problem there. Let's do one more application. We'll see how you do. The owner of a candy store is mixing candy worth $6 per pound with candy worth $8 per pound. She wants to obtain 144 pounds of candy worth $7.50 per pound. How much of each type of candy should she use in the mixture? Well, the first thing we need to do is define a variable. Let's let n equal number of pounds costing $6. And so given the other information that we have, that she wants it to be a total of 144 pounds, we can say let 144 minus n equal the $8 per pound candy. Okay, so if I organize my information here, $6 candy, I'm going to have n pounds. $8 candy, I'm going to have the total amount, 144 pounds. That's the total amount of both minus n. Because if I take away this one, then I will be left with whatever else is going to be in the $8 candy. Alright. Remember the $7.50 candy, I want $144. Pounds. 144 pounds. Now, the $6 candy, remember, costs $6 per pound. $8 candy costs $8 per pound. And the $7.50 candy costs $7.50 per pound. So the value of the candy is found by taking the number of pounds, multiplying by the price, and that gives you the value of the candy. So this would be 6n. This would be 8 times 144 minus n. And this last one here is going to be 144 times 750. And I'm just going to do the math real quick. That gives me 1,080.
Okay, so now we're going to take that last column, and if I add together the $6 candy and the $8 candy, I should get the total 10,080. So I'm doing 6n plus 8 times 144 minus n is equal to 1080. So now I'm going to do a little distribute. I'm going to solve for n. This is going to give me 6n plus 8 times 144 gives me 1152 minus 8n equals 1080. Combine some like terms. Gives me 1152 minus 2n. They're on the same side, so just add them together. Opposite operation. Gives me negative 2n equals 1080 minus 1152. Gives me negative 72. Divide both sides by a negative 2. And so n is 36, I believe. Let me double check my math. Yep, 36. What was n again? N was the number of pounds costing $6. So how much of each type of candy should she use in the mixture? 36 pounds of $6, 144 minus, oops, I push plus, minus 36 gives me 108 pounds of the $8. Now, I know all of these problems today have been very complicated. They are application problems. They are meant to be complicated. You are not going to be tested on each one of these types of problems. Maybe one of them will show up on the test. And maybe you'll be given options. But I'd like you to attempt them today. Use the Help Me Solve This to get you there. But you've got some practice on My Math Lab, and I'll be around to help you.